Ladies and gentlemen, today I will be presenting on mathematics. On mathematics today, I will also be discussing on one of the branch of mathematics called probability. On probability today, I will also be discussing on independent events. On independent events today, I will also be talking about the probability of independent hunters hitting a target. On this note, ladies and gentlemen, I was told that probability is a branch of mathematics that measures how likely an event is to happen. And I was also told that independent events are events where one outcome of the event does not affect the outcome of another event. On this note, ladies and gentlemen, I was told that probability was introduced or developed by Blaise Pascal and Pierre de Fermat, specifically in the year 1654. On this note, ladies and gentlemen, based on this information given, we'll be looking at our problem to solve. On our problem today, and our problem reads the probability of hunters P and Q hitting their target are 1/3 and 2/5 respectively. Find the probability that whenever they aim at the target, that both hit the target. B, both miss the target. C, only P hits the target. And D, only one hits the target. On this note, ladies and gentlemen, and based on this information given, we'll be looking at a problem to solve. In looking at a problem to solve, this problem involves two independent events, and these two independent events are the hunter P hitting the target, while hunter Q also hitting the target. These are the two independent events involved in this problem. So on this note, ladies and gentlemen, we say data. On our data today to solve our problem, we say the probability of P hitting the target is equal to 1/3, while the probability of Q also hitting the target is 2/5. On this note, ladies and gentlemen, we say the probability of both hit their target will definitely be equal to question mark. Why be the probability that both miss the target will definitely be equal to question mark. And C, the probability that only P hits the target will definitely be equal to question mark. While D, the probability that only one hits the target will definitely be equal to question mark. On this note, ladies and gentlemen, we'll be looking at our problem to solve. Based on our problem today, we say solution. On our solution today, we say A, the probability that both hit their target. The probability that both hit the target will be expressed as the mathematical formula. The probability of parenthesis open P and Q parenthesis closes. It can be expressed as the probability of parenthesis open P intersection Q parenthesis closes. On this note, ladies and gentlemen, we'll be looking at this mathematical formula just to solve our problem. So we say the probability of P hitting the target is 1/3 times the probability of Q also hitting the target is 2/5. What do? We say we'll multiply 1 and 2 just to get our answer. And at the same time, we also multiply 3 and 5 just to get our answer, ladies and gentlemen. So 1 times 2 is 2 over 3 times 5 is 15. So our answer here is 2 over 15 for the probability that both hit the target. On this note, ladies and gentlemen, we say B, the probability that both miss the target. The probability that both miss the target. The probability that both miss the target will be expressed as the mathematical formula. Probability of parenthesis OP, P, the complement, intersection Q, the complement, parenthesis closest. And it can also be expressed as the probability of parenthesis OP, P prime, intersection Q prime, parenthesis closest. Remember, both P and Q miss the target, so they are being expressed as a complement or prime. On this note, ladies and gentlemen, the probability of P missing the target is parenthesis of P 1 minus, and the probability of P is 1 over 3, parenthesis closest, times what the probability of Q missing the target is parenthesis of P 1 minus, and the probability of Q automatically become 2 over 5, parenthesis closest. What do? We say parenthesis open will be multiplying 1 and 3, and also be multiplying 3 and 1. So 1 times 3 or 3 times 1 get 3. What we have here minus 1 over 3, parenthesis closest. What we have here times, parenthesis open, 1 times 5, the same thing apply here, or 5 times 1 is 5. What we have here minus 2 over 5, parenthesis closest. What do? We say when we subtract 1 from 3, automatically we'll have 2 over 3 times. When we subtract 2 from 5, automatically we'll have 3 over 5. Ladies and gentlemen, to get our answer, we'll be multiplying 2 and 3, and at the same time, we'll also be multiplying 3 and 5 just to get our answer. So we say 2 times 3, automatically we'll have 6 over 3 times 5, we definitely get off 15. This can be reduced by 3. So we say 3 into 6 2 times, and 3 into 15 5 times. So we have 2 over 5 as our answer for the probability that both miss the target. Ladies and gentlemen, we say C, the probability that only P hits the target is the probability that only P hits the target. The probability that only P hits the target will also be expressed as the mathematical formula. The probability of parenthesis OP, P intersection Q, complement, parenthesis closest. And this can also be expressed as the probability of parenthesis OP, P intersection Q prime, parenthesis closest. Ladies and gentlemen, remember that P is hitting the target while Q is missing the target. So on this note, we'll be expressing P hitting the target to be 1 over 3 times parenthesis OP while Q missed the target is 1 minus, and the probability of Q automatically is 2 over 5, parenthesis closest. What do? We say 1 over 3 times parenthesis open, 1 times 5, and 5 times 1 automatically will get 5 minus 2 over 5, parenthesis closest. What do? We have 1 over 3 times 1 will be subtracting 2 from 5. If we subtract 2 from 5, automatically we'll have 3 over 5. Ladies and gentlemen, remember to get our answer, automatically we'll be multiplying 1 and 3 just to get our answer. At the same time, we'll also be multiplying 3 and 5 just to get our answer. So 1 times 3 is 3 over 3 times 5, automatically get off 15. But it can be reduced. 3 into 1 times 3 into 15 5 times. So it's 1 over 5. Ladies and gentlemen, this is the answer for the probability that only P hits the target. So on this note, ladies and gentlemen, we'll be finding the probability that only one hits the target, which is letter D. So on this note, ladies and gentlemen, based on our problem and the information given, we say the probability that only one hits the target. The probability that only one hits the target will be expressed as the mathematical formula. Probability, parenthesis open, P intersection Q, the complement, parenthesis close, plus the probability of parenthesis open, P prime or complement intersection Q, parenthesis closes. This is a formula we'll be using to solve our problem. But remember, on this side, P hits the target, while Q makes the target. At the same time, on this side, P makes the target, while Q hits the target. Because we don't know which one hits the target. So on this note, ladies and gentlemen, we say the probability of P hitting the target is 1 over 3 times. Parenthesis open, the probability that Q makes the target is 1 minus, and the probability of Q is 2 over 5. Parenthesis closes. Plus, we have the probability of P missing the target is parenthesis open. 1 minus, and the probability of P is 1 over 3. Parenthesis closes. Times the probability of Q hitting the target is 2 over 5. What do we do, ladies and gentlemen? We say this is expressed as 1 over 3 times. What we have 1 times 5, or 5 times 1 in parenthesis, we get 5 minus what we have here, 2 over 5. Parenthesis closes. Plus, parenthesis open, 1 times 3, or 3 times 1, we get 3, or we have here minus 1 over 3. Parenthesis closes. Times 2 over 5. What do we do? We say 1 over 3 times, if we subtract 2 from 5, automatically we have 3 over 5. Plus, what do we do? If we subtract 1 from 3, automatically we have 2 over 3 times 2 over 5. So ladies and gentlemen, we'll be multiplying 1 and 3 just to get our answer. At the same time, we'll also be multiplying 3 and 5 just to get our answer. And we'll also be multiplying 2 and 2 just to get our answer. And at the same time, we'll be multiplying 3 and 5 just to get our answer. So on this note, ladies and gentlemen, we say 1 times 3 is 3 over 3 times 5, automatically we have 15. What do we have here? Plus 2 times 2, automatically we have 4 over 3 times 5, we also have 15. What do we do? Remember that our denominator here are the same. So what do? We take 1, 15 here, automatically we take 1, 15, and we'll be adding the numerators. So the numerator here is 3 plus what we have here, 4. So if we add 3 plus 4, automatically we get 7 over 15. And this is our answer for only one hits the target. Ladies and gentlemen, our answer for both hit the target is 2 over 15. And our answer for B, both miss the target, is 2 over 5. And at the same time, our answer for C, only P hits the target, is 1 over 5. Automatically, our answer for D, only 1 hits the target, is 7 over 15. On this note, ladies and gentlemen, I remember Jacob Bernoulli, one of the greatest mathematicians, who also made a contribution to probability today. He developed or introduced the laws of large numbers on a probability between 1655 to 1705. That was Jacob Bernoulli. On this note, ladies and gentlemen, thanks for joining me on this math journey. Keep practicing, keep putting limits, stay curious, and let us come to Diva Vitis. Always remember that mathematics is the key. Don't forget to like, share, stay tuned, subscribe, and comment in the comment section. Once again, I'm P. Bomasia Jr., popularly or commonly known as Chachi, the all-time record breaker. Thank you.